Hello students, welcome back. Welcome back to Pebbles SSC Geometry Chapter 1 Similarity. Now we are going to solve exercise 1.4. Okay, let us see the first example. In first example there are three sub examples. The first example, two triangles are given. Now again I am not going to draw the figure, and since this example is extremely simple, I am not going to solve these three also. Okay, so first draw the figure, triangle ABC similar to triangle DEF. First sub questions. Now they are given the areas of triangle or the sides, and you have to find another area or another side. First sub question is, if area of triangle ABC is 9 centimeter square and area of triangle DEF is 64 centimeter squares, mind well, both are perfect squares. Okay, DE is 5.6, then find AB. Very simple, that AB square, area of triangle ABC upon area of triangle DEF is equal to AB square upon DE square, and hence you can easily find out AB. Nothing difficult in this. Please pause your video here and solve example number 1 now. I hope you have the book open with you, and books and notebooks and pens are also ready with you. Okay, so please pause your video here and solve first sub question of 1.41. Second, they are given if area of triangle ABC is the ratio of area of triangle ABC and DEF are 16:25, BC is 2.2, and then find EF. Again very simple, you just have to area of ABC and area of DEF, that is 16/25, is equal to BC square upon EF square, and you have to find out the EF. Deliberately they are given the perfect square. 16 and 25 are also perfect squares. The third sub question is, if now two sides are given, AB 2.4, DE 1.6, find the ratio of areas. Now ratio of areas of two similar triangle is equal to ratio of squares of corresponding sides. So you have to just 2.4 square upon 1.6 square is the ratio of their corresponding areas also. Let us see second example. Example number 2, the corresponding altitudes of two similar triangles ABC and PQR are given as similar triangles. These two are the heights of the triangles, 6 and 9 they are given respectively. Find a ratio of their areas. Now in this case I told you that the ratio of areas of triangle is equal to ratio of squares of their altitudes also, but that is not theorem. Okay, we proved that, right? So here what the theorem is, the ratio of area of triangle is equal to the ratio of squares of the sides. That means this area upon this area is equal to AB square upon PQ square. That is the theorem. But altitude square ratio is not a theorem. So first you have to prove that AB upon PQ is equal to AD upon PE. As we proved for the altitude, we have to prove this first. How will you prove that? Now since these two triangles are similar triangles, angle B and angle Q are congruent, then angle D and angle E are right angle. So by the AA test of similarity, what we can say that ABD and PQE are also similar triangles, and hence we can write that AB upon PQ is equal to AD upon PE. First you have to prove this one. First you have to prove this, and then you can say that by the theorem the area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square, which is nothing but AB upon PQ is equal to AD upon PE. So AB square upon PQ square is equal to AD square upon PE square. Okay, you cannot directly write this because this is not a theorem. Okay, example is very simple. Okay, immediately after looking at the figure, you may commit a mistake that directly writing this and writing 6 square upon 9 square. Okay, but that is not correct. You will get only half of the marks because you are stating something which you have not proved or which is not a theorem. So this is the only hitch in this problem, and now you can write that is equal to 6 square upon 9 square, that is 2 by 3 square, that is 4 by 9. I hope you understood this, why you have to prove this first. And this happens for medians also, because the median, in case of median also, that is not a theorem. We prove it in this way. Correct? We prove in this way, and then we say that the area is, a ratio of area is equal to ratio of squares of the median. So this is the only hitch in this problem. Don't forget to prove this first and then solve this. Otherwise, you will get the answer correct, no doubt in that, because this is very simple. But if you don't write this, if you don't prove this, your half of the marks, or rather I'll say 75% of the mark in this problem will cut. So pause your video, solve this example perfectly, and then we'll move ahead to third example. The third example is exactly similar to this one. The areas of two similar triangles are 81 centimeters square and 49 centimeters square. The names of the triangles etc. are not given. Find the ratio of their corresponding heights. What is the ratio of their corresponding medians? Now we know that the 81 and 49 are again the perfect squares. So the ratio will be 9 by 7 directly. You can find out the answer orally also. But again, the theorem says only the side squares and not the height square and median squares. Now in this case also, they have asked the ratio of medians and ratio of heights. Maybe in your digest or notes or somewhere else it is given directly that area 1 upon area 2 is equal to median 1 square upon median 2 square, or equal to height 1 square upon height 2 square. But mind well, you have to prove that first and only then you can state that. Okay, so please pause your video. We have already seen about the median and height both, how to solve. In this example we saw the how to find a ratio of heights. Previously we saw the medians also. So please pause your video right now and solve this problem properly. It may happen sometimes that the marks for this particular problem are less, 2 marks or 3 marks, but your solution is bit longer, but there is absolutely no alternative for you to prove the first and then find out the ratio. Okay, so please pause your video and solve this example right now. Example number 4. The figure is given. Segment DE is parallel to segment BC. DE is parallel to BC. Now D is parallel to BC and AB is a transversal. Now here there are two parts of this, two sub questions are there. The first is DE is 4, BC is 8 and area of triangle ADE is 25 centimeters square. Find the area of triangle ABC. Now in this case DE parallel to BC and AB is transversal. So this angle is equal to this angle. Correct? Now in these two triangles, that is ADE small triangle and ABC bigger triangle, angle A is common and D is equal to BC. So by AA test of similarity, triangle ABC is similar to triangle ADE. Now the first part of this problem is, if DE is 4 and BC is 8, area of triangle ADE, smaller triangle, is 25 centimeters square, then find the area of this bigger triangle ABC. Now here DE is parallel to BC and AB is transversal, so angle D and angle B are congruent angle because they are the corresponding angles. Now in these two triangles ADE and ABC, D and B are congruent angles and A is common angle. So by AA test of similarity, I can say that triangle ADE is similar to triangle ABC. Now there are two parts of this problem. So in every part you don't have to prove this similarity. You prove it only once and use in the second also. Okay, there you can write the first statement as this and it is already proved. Okay, so now they say that when the ADE and these are similar triangle ABC, then they say that DE and BC are given, D and BC are given. So the first is area of triangle ADE upon area of triangle ABC is equal to DE upon DE square upon BC square, and DE they are given 4 and BC 8. 4 square upon 8 square, and here also they are given the ADE 25 square is equal to 25 upon area of triangle ABC. From the second step you will get this and you have to just find out the area of triangle ABC. So please pause your video here and find out the answer of area of triangle ABC, then we'll move to second part of it. Please do it now. The answer is area of triangle ABC is 100 centimeter square. Don't forget to write unit of the area of triangle centimeter square because these lengths are given in centimeters. So now let us move to second part of this problem. The second part of this problem is DE upon BC is 3 upon 5, is 3:5. DE upon BC is 3:5. What they were asked? Find area of triangle ADE upon area of, find area of triangle ADE is to area of quadrilateral DBCE. Now here we have to prove that or find the ratio of this triangle area upon this. This ratio we already have. The first step is very similar. You have to first prove ADE similar to ABC. Now in this case, since this problem has two parts and in the first part you have already proved these two triangles are similar, you need not prove it again. You can just say that proved in the first part. But suppose there are no two parts and only second part is there. The example consists of only second part. Then you have to prove this again. You have to prove it first and then solve. But suppose two parts are there as in this case, then you need not prove again in the second part. You can just write that it is proved in the first part. Understood? So the first step is you have to first prove that this is two triangles are similar triangles. Okay? Let us go ahead now. So area of triangle ADE upon area of triangle ABC is equal to DE square upon BC square is equal to 9 upon 25. Now we know that this ABC, this bigger triangle, consists of one small triangle and one quadrilateral. So what I'll do that, I will first take this ABC up. So by the invertendo, what I'll do, area, I'll not write that triangle sign, okay? ABC upon area of ADE is equal to 25 upon 9. But ABC is nothing but area of ADE plus area of quadrilateral BDEC upon area of ADE is equal to 25 upon 9. Okay, but what I want, ADE upon DBCE, but here that quadrilateral is not alone, plus ADE is also there. So what I'll do the dividendo here. When I do dividendo, from this I will subtract ADE, and from here 25 I'll subtract 9. So what I will get, area of ADE plus area of quadrilateral BDEC minus area of ADE upon area of ADE is equal to 25 minus 9 upon 9. 25 minus 9 upon 9. So further I'll write it here. So here ADE and AD will get cancelled, and now you have got area of quadrilateral BDEC upon area of ADE is equal to 25 minus 9 upon 9 is equal to 16 upon 9. But what we want a ratio of ADE and ADE to quadrilateral. So again I will do invertendo. By invertendo, I'll say that area of ADE, write the triangle sign, okay? I'm not writing, but you write. And area of quadrilateral BDEC is equal to 9 by 16. So this problem is not very difficult. First of all, you have to do invertendo, then dividendo. Okay, so the main question in the student's mind is like this: when should we use invertendos and dividendos, and why? Okay, as in the case of similarity chapter, I told you that unlike other chapters, here you have to use all your basic knowledge, like your corresponding angles between the parallel lines, and then the invertendos, dividendos, everywhere. But my question was, when I was in school, when we should use this invertendo and dividendo and all those things, and how? I never asked this question to my teachers because it was fear that other students will laugh at me. But this was a genuine question. Okay. Now, how I solved this problem myself, that I'll tell you. Okay. First of all, it was sure in my mind that if the problem is unsolvable, if the problem has no solutions, they will not give you in the exam. So whatever problem is there in your exam paper, solution is there. Okay. So here also what I thought, we have to find this. Okay. ADE and quadrilateral DBCE, and they gave that DE upon BC is equal to 3:5. That means I have to use DE upon BC. Definitely I have to use. And I also know that if DE upon BC is there, that means definitely ADE upon ABC is there. Okay. So the first step I written here, ADE upon ABC. Now we know that ABC has got one triangle and one quadrilateral, and whenever we have to use that, it is always better that the longer expressions should always be as a numerators, and hence I did this invertendo. Okay, first of all I wrote here DE upon BC, whichever is given. I went by the reverse engineering. First I wrote DE upon BC, so correspondingly the triangles are here, ADE, because it is correspond to D, and ABC here. After this, I know that ABC has got two areas, one triangle, one quadrilateral. So if I substitute it here like ADE plus BDEC, then what will happen? That will go on the denominator, and it is always better that the expressions should always be on the numerator side. So that is why I am doing invertendo. And now my expression, bigger expression, has come on the numerator, and this single one ADE has gone to denominator by invertendo. Now when I look at this, what I want here, ADE and DBCE. So DBC is there, AD is there, but this I want to cut. How will I able to cut? So I use the dividendo. So I can cut this, so the only these two are remaining, and I solved the example. So always remember, you can go by the reverse engineering. When they have given this, that means definitely the areas are there in the ratio. So first write corresponding areas. So once you have written DE upon BC, immediately write the area of ADB upon ABC, and then square of this. So this expression you have got, and after that you go on reverse engineering the things. I hope you have understood this. If you have not understood, watch this video again, and still if you have not understood, just remember how to solve such problems. Okay, this is the method. But if you try to form your own methods of remembering something, that will be useful for you for solving the future examples. Okay, so now please pause your video. I already solved it up to end, but still pause your video and solve this example perfectly. Then we'll go to the next example. Example number 5. The figure is not given, but still I have drawn the figure. You also have to draw the figure. In triangle ABC, PQ is the line segment intersecting AB at P and AC at Q, such that the segment PQ and BC are parallel lines. If PQ divides triangle ABC into two parts equal in area, if this divides this triangle ABC in two parts equal in area, that means if the area is equal, then means APQ, area of triangle APQ, is half of the ABC. Area of triangle APQ is equal to half of area of triangle ABC. This we can know from the given. Find BP upon AB. Find BP upon AB. BP upon AB. Now how will you solve this? Now if you don't understand how to solve, first of all, this is the problem of similarity. Area of triangles are given ratios. So first of all, we will prove that these two triangles APQ and ABC are similar triangles. How will we solve this? Very simple. These two lines are parallel, line segments are parallel, AB is a transversal. So these two angles are congruent. Angle A is common angle. So by AA test of similarity, triangle APQ is similar to triangle ABC. Correct? So now what we want to find out? BP upon AB. AB we want to find out. So here AB and AP is there, corresponding sides. Correct? BP is not there, but AP is given. So first of all we'll write what we know. That is the theorem on areas of triangles, similar triangles. So I will write down area of APQ upon area of ABC is equal to AP square upon AB square. But we know that area of triangle APQ is half of the area of triangle ABC. So 2APQ is equal to ABC. So I can write that area of triangle APQ upon twice area of triangle APQ is equal to AP square upon AB square. Correct? So we have AP square upon AB square is equal to 1 upon 2. But we don't want squares here. So what I'll do? We'll take square root of both the sides, and so we have AP upon AB is equal to 1 upon root 2. What we want? BP. What is BP? BP is nothing but AB minus AP. AB is also here, AP is also here. So we can easily make AB minus AP as a by doing the dividendo. But what will happen? AB is down here. So I'll have to first do invertendo, and hence by invertendo, I'm not writing by invertendo, you write down, or let us write down. By invertendo, I will have AB upon AP is equal to root 2. Now by dividendo, I will do dividendo AB minus AP upon AP is equal to root 2 minus 1. And AB minus AP is nothing but BP. So I will have BP upon AP is equal to root 2 minus 1. So now we have two things. First we have got this as 1 and we have got this as 2. What we want? BP upon AB. But what we have here? AP upon AB and BP upon AP. So if we multiply 1 by 2, what will happen? This AP will get cancelled. So multiplying, that is equation 1 into equation 2, what will have? AP upon AB into BP upon AP is equal to 1 upon root 2 into root 2 minus 1 upon 1. So this AP will get cancelled and we will have BP upon AB is equal to root 2 minus 1 upon root 2. This is your final answer. So I hope you have understood this. So please pause your video here and solve this example by yourself by writing properly all the steps. Okay? You have to prove also that these two triangles are similar triangles. So please do it now. Pause your video. Now let us solve the last example of exercise 1.6. In triangle ABC, again the figure is not given, but you have to draw the figure. Okay? In triangle ABC, segment DE is parallel to BC. If two area of or the twice area of triangle ADE twice area of triangle ADE is equal to area of quadrilateral DBCE. Area of quadrilateral DBCE. This is given two things they have asked. The first, find AB upon AD. Find AB is to AD. Find the ratio AB is to AD. And secondly, we have to show that BC is equal to root 3 DE. BC is equal to root 3 DE. Now, how will you solve this? First of all, it is very simple. AB upon AD. AB upon AD. We have to find. That means if we can find the ratio of the areas, first of all, we have to prove that these two triangles, this smaller triangle ADE and bigger triangle ABC are similar. After that, if you can find a ratio of area of triangle, then AB upon AD is not difficult at all, because we know the theorem on areas of triangle, okay, that is equal to the ratio of squares of the corresponding sides. So AB and AD are the corresponding sides, correct? And similarly BC and DE are also corresponding sides of these two similar triangles. But they have not at all given how to find the areas, ratio of the areas, but they have given something different, twice the area of ADE. That means this smaller triangle, twice the area of this triangle is equal to the area of this quadrilateral. Okay, so how should we proceed? The first, we will see that the area of triangle ABC is nothing but the area of triangle ADE plus area of quadrilateral DBCE. And they are already given DBC is equal to twice ADE. So this is equal to area of triangle ADE plus twice area of triangle ADE. And so we have thrice the area of triangle ADE is equal to area of triangle ABC. So now you have got the ratio of areas of two triangles, that is area of triangle ABC upon area of triangle ADE is equal to 3:1. Correct? Now we will prove. This is the first part. We have found out the hidden values of the ratios of the areas of two triangles. But yet we don't know. They are not given that these two triangles are similar triangles. So as a second step, we will prove that these two triangles ADE and ABC are similar triangles. Very simple. How will you prove that? They are already given that they are already given DC and BC are parallel. So when DC and BC are parallel, AB or AC are transversals. So the corresponding angles, these two angles are congruent, and angle A is common angle. So by AA test of similarity, ADE is similar to ABC. Or you can write ABC is similar to, I can write ABC is similar to ADE. So when this is proved, this is what we have to find out, AB upon AD. So this is nothing but AB square upon AD square by theorem on areas of similar triangle. So your AB upon, and hence your AB upon AD is nothing but the square root of 3. Correct? But BC and DE are also corresponding sides. So I can write that BC square upon D square is also equal to 3 from this. Correct? And so what is BC upon D then? Is equal to root 3. And so you take DE to that side. So BC is equal to root 3 DE. Proved. Correct? So what trick they did in this case? First of all, they did not mention the ratio directly. Ratios of areas of triangle directly they did not mention. So first we found out that. And after that, we proved that. Always remember, in case of similarity, you will feel that the problem is very simple. You can easily find out the answer orally also. But first check whether they have given that those two triangles are similar or not. Because whatever rules or theorems you are applying are for the similar triangles. So unless and until you prove that these two triangles are similar, you cannot apply those theorems or the postulates or the ratios directly. So please pause your video and solve this example after finishing this video, maybe, because this was the last example of exercise 1.4. So friends, here we are finishing the exercise 1.4 and we will go ahead to next topic. Thank you very much.